Okay, so imagine somebody says, come up with a precise set of directions for getting from point A to point B, right? Each one of these squares is 1 meter of distance. And you've got to come up with directions. Well, those directions would be a vector, okay? So a vector is anything that has a magnitude. Magnitude just means like a number, how big it is, right? He's 6'2", right? Okay, and a direction. So if I say move 5 meters east, that would be a vector, okay? So if I give directions from A to B, those directions will be vectors. Let me just show you this, right? One possibility, and kids always come up with this, is let's just say let's move to the right and then let's move up. Let's follow the grid lines, okay? If you do that, you're going to go 4 meters, and this is, by the way, in the positive x direction, right? Okay, so in physics land, we actually say in the x direction by putting x with a little hat on it, right? And then we would be 3 meters in the y direction. And so we would write this, I call these VC, vector component vectors. Okay, and I know that's kind of redundant, but maybe nobody else calls it. Maybe it's just a component vector, I don't know. Okay, but you would write it this way. To get from A to B is go 4 meters in the x direction. So that just means in the x direction plus 3 meters in the y direction, okay? Always put your x first, put your y second. If the y happens to be negative, I was taught in college that you should say plus a negative, okay? But other than that, there's no real nuance here, okay? The little hat thing there, you can either read this 4 meters x hat, 3 meters y hat, or you can say 4 meters in the x direction plus 3 meters in the y direction. Notice that when you draw the components that they are tip to tail, right? We go here, and then from there we go up, right? It's like continuing directions, right? The other way we could do it is if you're sort of a more direct person, is we could just go, wow, that's a good straight line there. That's as straight as you can draw them, right? If this is 3 and that's 4, then that's a 3, 4, 5 right triangle, right? So that's 5 meters. We could say, and by the way, this angle here is approximately 36.87 degrees. And I did that by finding the inverse tangent of 3/4, right? And I was in degrees, right? So I could say, and this is, by the way, called an angle magnitude vector. I could say 5 meters, 36.87 degrees above the x-axis. I guess we'd say, I draw this picture, by the way. I just draw this, label that angle, I'm good, right? If I had to say it in words, I'd say 36.7 up and right. 35 meters, 36.87 degrees above the x-axis, right? Or, if we were doing north, south, east, west, we could do some angle off of north. This is an angle magnitude vector. Angle magnitude vectors, and this is very hard to remember, okay? Angle magnitude vectors actually have an angle and a magnitude, okay? And that's why they're called angle magnitude vectors. Are you laughing? I just can't tell if you're laughing at that.